And last but certainly not least, we have a group here today to talk to us from the Boy Scouts of America. We have Elliot Lee, who is a scout with Troop 209, Andrew Frank, scout with Troop 209, and Norman McFarland, the team leader, also with the Boy Scouts of America.
Hello, my name is Elliot Lee, and first slide, please. I'm going to be talking to you about the experiment, and I'm going to introduce you into what we're about to do. Oh, can we have the first slide? Yeah. Uh, so our experiment is we're going to use an organism and a known cancer-causing substance, and we're going to use that to measure the time and mutation rate on the microgravity versus gravity on Earth. This could be actually a huge impact on human tissue growth / cancer research. The Ames test is originally used with an organism and a suspected cancer-causing substance, and but we use the direct opposite of that, and we use a known cancer-causing substance and an organism to measure the rate between Earth's gravity and space gravity. Next slide, please. So as you can see, we have different concentrations, and each concentration has different mutation rates. Also, some of the Ames test, it could originally be used, and some of the concentrations that it uses is 4-NQO, also known as nitroquinone oxide. Oh yeah, what was it? Oh yeah, and our account, no, not an account. Yeah, our concentrations are 1 to 2, 1 to 4, 1 to 8, and so on until 1 to 64. And some of our original well designs were, we were going to use actually an entire well plate, but that was too hard. And we were going to make it circular, but that was also too hard. So we made an octagon-shaped cylindrical use, and we made it 5x14, 8 well plates. And next slide, please. Yeah, so in this slide, after the test, we're going to be reviewing the pictures, and once we review the pictures, we're going to log them by hours, and we're going to count how many mutation cells have happened. But we have to take note of the environmental effect around it. So here are the 3 sensors: temperature, humidity, pressure sensor. Then there's the light sensor, and then there's the radiation sensor. We got to take note of each environmental effect to see how each affects the mutation rate, and they're going to be logged into our SD card in the NESI board. Once these are logged, we're going to test our hypothesis, and our hypothesis is, will the E. coli mutate faster in microgravity than on Earth's gravity? And I'll pass it on to Andrew Frank.
So basically, we have all these sensors, and we're trying to get the environmental data back so that we can run a similar test on Earth as close as possible to the one that's running on the space station, except for gravity. And so that's why we have all these sensors. We actually had so many that we had to use an inter-integrated communication system because we didn't have enough inputs on our NESI board, which was provided by Texas A&M. Next slide, please. So the organism we're using, we froze it in -20 degrees Celsius freezer, and that's to ensure that the experiment doesn't begin before it actually gets to the space station. So here you can see that's our NESI board. We were soldering wires directly onto it, and it was causing a lot of damage. So if you go to the next slide, you can see we have a custom circuit board that holds 2 cameras and the sensors to monitor environmental variables within the chamber, as you can see here. If you go to the next slide, you can also see this other custom board that we've created, and that whole that connects everything. It really cleaned up a lot of the wires for us. If you go to the next slide, you can see this is a sketch. We tested a bunch of motors to find the perfect one that worked with this test. And this is just a sketch of one of the assemblies we used for testing it. If you go to the next slide, you can see that we are not the only people working on this. There's like a whole team behind it. You can see us. We took a picture with Mark Polinsky, who was an astronaut on the ISS. And if you go to the next and final slide, you can see all our sponsors that we would like to thank for helping us out. And now I'll pass it off to our adult leader, Mr. Norman McFarland.
Hello, everyone. As project leader, I could not be more proud of these boys. I could also use the microphone. As project leader, I couldn't be more proud of these boys. They started off as a bunch of bright-eyed school students, and now they're self-starting, problem-solving young engineers. They're just doing they've done a phenomenal job. For those of you that think that scouting is all about camping or campfires or knot tying or whatever else your preconceived notion, maybe you can see now that we do some STEM stuff once in a while. We actually offer over 60 merit badges in the science, technology, engineering, math area. In addition to that, we have several different Novus awards for special studies into the STEM area, and beyond that, once you have some NOVA awards, you can earn Supernova awards, the top of which belongs on your college resume as a significant event there. So our team would like to thank NASA for this TV time, CASIS, NanoRacks, Texas A&M University for sponsoring this team, General Kinetics, EBPI was our biology source, and SparkFun for many of the sensors that you saw here. Finally, we have a very special thanks going out to two people, Nan Elder and Lisa Early, who were former Scout Council and district STEM professionals that set up this program so that we could be up here today. We also, of course, would like to thank our sponsoring organization, the First United Methodist Church of Palatine, Illinois. Thank you for your time.
Thank you all for your presentation. Do we have any questions in the audience for the Boy Scouts? Do we have any questions on social media? Oh, we do have one question. Wait for the microphone, please.
I'm just curious, how long has it taken you guys to get from the idea to do this to where you are now?
It's been around 2.5 years since we started.
Just an add-on to that, some of that was we were going to fly our unit to space frozen, and we had a couple launches that would not have a freezer of the proper temperatures. So that wasn't all just us taking that long, but we used the time when we got it.
Any other questions in the room?
Hi, my name is Maria. I was wondering what inspired you to choose your project.
So I have a career path that I want to share with you. Actually, I kind of wanted to be an engineer in the U.S. Army. So and then this project really inspired me to do that sort of career path. So then I just wanted to learn more about such things, and it really helped me out as a life lesson.
I'm sorry, were you asking how each of the boys chose to be on the team, or were you asking how we chose this particular experiment to run?
Yeah, the particular experiment.
We went to the troop. I'm sorry, I'll answer. You want to do it?
Sure. Yeah, so we went to the troop. It was a pretty big troop, around like 100 kids in it, and we asked them to submit their ideas. And so we spent a lot of time just filtering through all those ideas. We ended up with about 4 at the end, right? And then we actually combined 2 of those suggestions to get our experiment as it is now.
We started off with 84 suggestions between boys and adults in a night. It took us about 2 more nights to filter through those. We did some rather tricky, get through them quick filtering, and this is what came out of it.
We do have a question from social media.
Yeah, this question asks, what is the suspected cancer-causing substance you're going to use for the experiment?
4-nitroquinoline oxide.
Okay, does that help? We were fortunate enough to have a Abbott microbiologist on the team, and so we started off with salmonella, and then we realized that any scout that got sick in the next 6 months, it was going to be our fault. So we switched to the E. coli, and that brought us back to this particular substance.
Any other questions in the room? Okay, thank you, gentlemen. Thank you to everyone who joined us for today's What's on Board. If you're following along online or in the room, thank you. We're excited to get ready for tomorrow's targeted launch at 12:31 p.m. Eastern Daylight Time. And don't forget, 9:33 this evening, if you're here on Florida Space Coast, look up for the station to go overhead. That's it for What's on Board.